Alright, in this second recording I'm going to do part 2 of problem number 142. Okay, in part 1 I found the function's inverse, that's right there, found the inverse. But what they want us to do is prove that the two are inverses, or show that they are, by demonstrating that the f of the inverse of f of x is the same as the inverse of f of x. And both of those are equivalent to x. So I'm going to focus on this first one here. It says find the composition of f and f inverse. Okay, so we just practiced this. I go f of, now it says inside put f inverse. So I run over here and grab f inverse. Let's put that in red so we can kind of match up colors. X minus 1 over 2. So that's one step. Just working straight down kind of on this left-hand function, composite function. Now I'm going to plug that into function f up here, and function f says take 2 times whatever you're plugging in. I'm plugging in the square root of x minus 1 over 2, and it says take that x value and square it, so I'm going to square it and then add 1 to it. Okay. When I try to simplify this now, I'm going to square the square root first, and that just eliminates the square root. Next, you can see this 2 is in the numerator. It will cancel that 2 in the denominator. And that simplifies to just x then, minus 1, plus the 1 that's on the outside, and that's going to equal just an x. So I've proven that left-hand side, the f of the inverse of f of x is equal to x. Okay, I cut some stuff now, and let's do that middle statement. This time I'm going to be working on this right here. It says f inverse. Let's again kind of match up our colors here. I use f inverse of, now I replace it with what f of x is. Remember, f of x is back over here. 2x squared plus 1. Now I'm going to run to function f, or the inverse of f, right up there. And it says the inverse of f is the square root of, here comes the substitution. I'm going to rewrite that in purple there. The square root of, here comes the substitution in for x, 2x squared plus 1. Then it says subtract 1, then divide it by 2. And that gives me the square root of, in the numerator, the 1 and negative 1 cancel. The 2 over 2 is just a 1, and I get x. So I've shown that f of the inverse of f of x is x, and that the f inverse of the f of x is also x. And therefore, the function and the other one that I found are indeed inverses of each other.